Hello guys, this is Prime Concept. Now I want to expand on the concept of electrostatics. I earlier introduced electrostatics in my previous video. So in this video, I would continue to expand on this concept. But before that, you would understand that electrostatics in itself is a compound word that is derived from two words, electro, which means electron, and electron, like we know, is a charge, and statics, right? Static simply means something that is at rest, something that is stationary. So electrostatics is the study of charges that are at rest, charges that are stationary, or charges that are moving very, very slowly. So that is electrostatics. And we established that one of the major laws that governs electrostatics is what we know as Coulomb's law of electrostatics. And Coulomb's law mathematically is given by the relation F equals KQ1 Q2 by R squared. So this is Coulomb's law. And this formula gives us the magnitude of Coulomb's law, the size of Coulomb's force. So that is what this formula gives us. Now, of course, Coulomb's law simply says when you have two charges, the force that will be experienced by those two charges is what is given by this. Now, let me quickly explain this again like I did before. Now, I will be explaining this from the idea of magnetism. Now, if I have a magnet, say this is a magnet and this is a nail. Now, by virtue of having this magnet here, this magnet would create a region or a field around itself, such that if I have a nail and I bring this nail somewhere outside that field or that space, this nail would not experience any attraction, right? But the moment I take this nail into the field created by this magnet, this nail will experience an attraction to the magnet, right? And this magnet that is creating that field is what you know as the source of the magnetic field. So this becomes your source. Then this one you are using to test for the strength or for the region of that magnetic field. You call this your test. So the same way in electricity or electrostatics, we have two kinds of charges, our source and our test charge. So if this is one charge, Q1, now by virtue of Q1 being here, it creates a field around itself. Every charge always creates a field around them. So if I have this as Q1, it creates a field around itself. And the field that is created by this charge is what we know as electric field. If I bring another charge, say this is another charge Q2, if I bring it inside the field created by this charge will experience either a force of attraction or a force of repulsion. So the magnitude, the size, how big that force of attraction or repulsion would be is what we have, is what is given by this relationship, the force. Now, this charge that creates that field is what you know as your source charge. This is the source. This is the charge that exerts a force on this one. So this one that is used to test for the field, or this one that experiences the force, is what you call your test charge. So in every Coulomb's problem, you always meet two kinds of charges. One of them is your source charge, then the other one is your test charge. Now, how do you know your source charge? Your source charge would always be the one that exerts a force, and your test charge would always be the one that experiences or receives the force, right? Now, we want to advance in this video. We'll be considering what we call Coulomb's law in vector form. Coulomb's law in vector form. This formula only gives us the magnitude or size. We want to consider another formula that will give us the direction. So that is what we refer to as Coulomb's law. Coulomb's law in vector form, right? So Coulomb's law in vector form is simply given as F equals KQ1 Q2 by R squared, then multiplied by the unit vector that gives us information about the direction. So this formula put together is what you know as Coulomb's law in vector form, where this unit vector gives us information about the direction of this force. And what is the formula for the unit vector? So the unit vector, this is given by R over the magnitude of R. So we'll be solving problems so that you can really understand this idea. But before that, the next thing we want to consider is the principle of superposition. Now, in a situation where we have more than two charges, say we have three charges or we have four charges exerting force on one single charge, how do we get the magnitude and direction of the force that that single charge or test charge would experience? So that leads us to the next principle, which is the principle of superposition. The principle of superposition. The principle of superposition simply says that if you have three or more charges exerting force on a test charge, then the net or resultant force that that test charge would experience is going to be the vector sum of each of those forces. If you have three or more forces exerting a force on a single test charge, then the magnitude and direction of the force experienced by that test charge is going to be the vector sum of each of those forces. Now, say we have Q1, Q2, Q3, up to Qn. We can have so many, Q5 and so on. And then we have the test charge here, Q0. So this is the force this would exert on this. This F20, the force. This F30, the force. And this is Fn0, the force, right? Now, according to the principle of superposition, the net force that Q0 would experience is going to be the vector sum of each of these forces. So mathematically, it will be given as net force equals F10 times this plus F20 times this plus F30 times this, and so on to Fn0 times this. So this is mathematical relationship for the principle of superposition, right? This concept, I believe, is very clear. In my next video, I'll be solving problems that would help us understand the principle of superposition and Coulomb's law in vector form. So thanks for watching my video. Do subscribe to my channel so that you can get more videos on this. Thank you. Remember, this is prime concepts.